Alright, in this video we are going to use reference angles to find the sine and cosine of theta, but this time we're going to look at it in terms of radians. So it's kind of putting the last two videos together. And so remember, first we're going to find out what quadrant it's in. We're going to figure out the reference angle. Once we know the reference angle, then we're going to use our reference triangles, and then we're going to see what's negative. And then from there, we'll be able to figure out everything else. All right, so on this one, we have 5 pi over 3. So if you recall from looking at the reference triangles, we know that this is 0, and this is pi. I want my denominator to be 3, so this is 3 pi over 3. And so this would be twice as much coming all around over here. And so 2 times 3 is 6 pi over 3. Now, I'm looking for 5 pi over 3. So coming around, it's going to be bigger than 3 pi over 3, but not as big as 6 pi over 3. Now, is 5 closer to 3 or to 6? Well, it's closer to 6, so it would be in this quadrant number 4. So here is 5 pi over 6, and so then I'm just going to subtract. Remember, it goes to the x-axis, so 6 pi over 3. I'm sorry, not over 6, over 3. I'm sorry. 6 pi over 3 minus 5 pi over 3 would give me pi over 3 as my reference angle. So this is 5 pi over 3, and then my reference angle is pi over 3. Now remember, the pi over 3 is 60 degrees, so this is going to be square root of 3, because across from pi over 3 is the square root of 3. So this is going to be 1, 2, square root of 3. So now we've used our reference triangles, so now we need to know what is negative. So starting at the origin and just traveling along this triangle, this is going to be in the positive x direction, but the negative y direction because I'm going down. Now let me make that look negative. And so when I want to know what the cosine of 5 pi over 3 is, it would be adjacent over hypotenuse, so this would be 1/2. All right? Problem number 2 says the cosine of 5 pi over 4. Right? So, again, I draw my axes. This is 0, and this would be pi. I want my denominator to be 4, so multiply numerator and denominator by 4. So I have 4 pi over 4. And then over here, this would be twice that. And so 2 times 4 is 8, so 8 pi over 4. So now coming around, I'm trying to get to 5 pi over 4, so it's going to be past 4 pi over 4, but not as quite as much as 8 pi over 4. 5 is closer to 4 than it is to 8, and so this angle will be in the third quadrant. So here's 5 pi over 4, so it always goes to the x-axis, so I'm just going to look at it. I'm going to say bigger one, 5 pi over 4 minus 4 pi over 4 would give me pi over 4. And so I know that my reference angle is going to be pi over 4. So now I'm looking at my reference triangles, and with a pi over 4, it's 1, 1, square root of 2. So this will be 1, 1, square root of 2. Now I want to see what's negative. So starting at my origin, notice I'm going in the negative x direction, so this will be negative, and I'm also going down, so this is also going to be negative. All right? And so the cosine is going to be adjacent over hypotenuse, and so that would be negative 1 over the square root of 2, or you can write it as negative square root of 2 over 2 if you rationalize the denominator. All right, problem number 3. let's do 2 pi over 3, and we'll do the sine of 2 pi over 3. All right, so 2 pi over 3. So here's 0, here's pi. So this would be 3 pi over 3, and then this would be twice that, 6 pi over 3. And so coming around, 2 pi over 3 is not quite as big as 3 pi over 3. So it would be in the second quadrant. Now I want to find my reference angle. So here's 2 pi over 3. My x-axis is 3 pi over 3, so I'm just going to subtract 3 pi over 3 minus 2 pi over 3 gives me pi over 3. So this angle here, here's 2 pi over 3, and then this is pi over 3. And you see 2 pi over 3 plus pi over 3 gives me 3 pi over 3. All right? So that's my reference angle. Now I want to look and see what are my numbers that go around. So I'm looking at my two little reference triangles up here. So opposite the pi over 3 is going to be the square root of 3. So this is going to be 1, 2, square root of 3. And then let's see what's negative. So starting here, I'm going backwards in the x direction, but I'm going up in the y direction. So that stays positive. So the x is negative, the y is positive. Now finding the sine of this angle, so using my reference angle, it would be square root of 3 over 2. So finally, let's do a negative one. So let's say we want to know what is the sine of negative pi over 3. So coming backwards, here's 0. Coming this way, I'll be at negative pi, and I want my denominator to be 3. So this would be numerator and denominator by 3. So this would be negative 3 pi over 3, and then continuing along, this would be negative 6 pi over 3. Now negative pi over 3 is not as big as negative 3 pi over 3, so it's going to be either in the third or fourth quadrant. And notice that 1 is closer to 0 than it is to 3. So this one's going to be in my fourth quadrant. All right? And so here is negative pi over 3. Now here, I'm not using this one, I'm using 0. So pi over 3 minus 0 would be pi over 3 as my reference angle. And you would know that a reference angle would not be, if you tried to use a 6 pi over 3, you'd get 5 pi over 3. That's too big. It should just either be, it should be one of these, either pi over 3, pi over 6, or pi over 4. So this is pi over 3, and pi over 3 opposite it is the square root of 3. So it's 1, 2, square root of 3. And then let's see what's negative. This is in the positive x direction, but this is down. So this one would be negative. All right, and so now what is the sine of negative pi over 3? Would be opposite over hypotenuse, so it would be negative square root of 3 over 2. The opposite is negative square root of 3, and the hypotenuse is 2. So that is how you find sines and cosines using reference angles with radians.